Hi. It's quite an annoying question or naughty question from Jan 2025. Crane on a ship can lift the submarine out of the sea. The submarine is initially completely underwater and at rest and below the surface of water. The cable from the crane is attached to the submarine so that the cable is vertical. The crane pulls on the cable, and the submarine moves vertically upward at constant speed until the whole submarine is out of water. And explain how the tension in the cable changes as the submarine moves from below the surface of the water to being completely out of water. You should assume the drag force on the submarine is negligible. So the point is, how can I get 6 out of 6? So this is the main problem here in physics. It's quite challenging for my students or for any physicist to get the 6 out of 6 according to this one, which is an asterisk question. When the submarine is fully submerged, what does it mean? So if I'm looking at the submarine as dotted, the free body diagram, so we have force, which is acting downward, which is the weight of the submarine, and weight here, which is mg. I have to say it's the weight of the submarine, okay? And there are two forces acting upwards. The U, which is up thrust force, so this one, which is up thrust force, and there is another force which is tension as a resultant force, or the tension in the cable. So vertically, if I'm moving with a constant speed in this section or the paragraph 2, the examiner is telling you the submarine moves vertically with a constant speed. We have to understand before and after, by the way, because he said it was completely underwater initially at rest. What does it mean as well? So let me break it down step by step. So for indicative point 1, what should I say? Initially, I think there is no vertical resultant force. Why? Because you are at rest. And this resultant force, by the way, is acting on the submarine, which it means submission FV on the submarine equals 0. Why? Because he said that because the submarines move at constant speed, so here constant speed, no resultant force. So if I want to go deeper to understand what are the forces acting, so look at a free body diagram. In the free body diagram, I said weight is acting downward, upthrust force and tension force. So you go down, just write the tension as a force equals to weight, which is acting downward, minus upthrust force, according to this equation. I think I deserve here 2 marks. 1 mark for explaining how much of the resultant force and applying Newton's second law of motion. By the way, just let the examiner knows the submission F vertical equal mass times acceleration vertically as well. So the acceleration here, which is 0, because it's a constant speed. The examiner said how the tension force changes. So the weight here, which is constant, just to let the examiner know that the weight of the submarine, I think it's always constant. There is no change. So right now the tension changes according to the value of the upthrust. If the upthrust is less or more, so the tension is directly proportional to the change to the upthrust. If the upthrust decreases, the tension is going to be higher. If the upthrust increases, the tension is going to be less. So, as the submarine leaves the water, so let me go through this one. As the submarine leaves the water, and this is what will happen with a shower and you are in a bathtub. If you are sitting in the bathtub, so the level of water slightly rises. Why? Because your body, imagine yourself like you are a submarine right now, so the water, the volume of water, the mass of the water being displaced quite high. But when you leave the bathtub, what will happen to you? The mass or the water being displaced is going to be less. So as the submarine leaves the water, so I would say the mass or the volume of the water being displaced is going to be less, decreases. So in this case, I have to use the equation tension equal weight minus upthrust. And I think your weight is constant, but the upthrust on the submarine decreases. So the upthrust as a force on the submarine decreases. As a result, the tension force here, which is weight minus upthrust, the weight, the displaced upthrust force, or the weight of the displaced fluid or water is less. So W minus U as a sum of forces will be higher. So the tension force here will be higher. So the tension force, this force where it's in the cable, you have to say this, is going to be higher. By the way, the function of the water or the job description of the fluid itself, the upthrust force is always supporting the cable. So if there is the submarine is out of water, it means less displacement of fluid and less upthrust force to help or support the weight itself of the submarine. So the cable must have or must carry more, so tension force increases. The final point, when the examiner said, so now I already explained what, as the submarine moves from below the surface of water as to being completely out of water. So as the submarine here is completely out of water, what do you think? Use the mathematical equation tension equals weight minus upthrust. But the submarine is already completely out of water, so what do you think about the W or the U? There is no more upthrust force. There is no fluid to displace being to displace. So the U is 0 as an upthrust force. So now T equals W. So now it's the whole load on the cable. So the tension in the cable is going to be more and more. So let me check with you guys according to the mark scheme. If we mention a kind of a polishing right now, the submarine moves at constant speed, so the resultant force is 0. I just add from my side, it's a vertical resultant force because I'm talking about the forces acting vertically on the moving submarine. Therefore, the tension in the cable equals to the weight of the submarine minus upthrust. This one I already mentioned. To get the second mark. As the submarine leaves the water, so this is really important because we need to know what happened to the tension force. I said the volume or the weight of the displaced water or the upthrust force decreases. This one already mentioned. So once you mention the upthrust force decreases because it's linked to the amount of water displaced is less. So you get indicative point 4 and 3 and 4, sorry. And for point 5, the resultant force here with which is the tension force in the cable, I get point 5. And the final one, so for indicative point 6, the submarine is completely out of water. So T equals W minus upthrust which is 0. So T equals W, so I get the 6 mark, or the last point. If you like the video, share and like, subscribe, and let me know which difficulties you might face in physics.